Hello, my name is Sarah Moeller, and I'd like to tell you a little bit about the interaction of artificial intelligence and linguistics, particularly the documentation and description of endangered languages, and also give some examples of potential applications of AI on these fields. I think to better understand where we are in the interaction between AI and linguistics, it's good to go back and understand the history of both fields a little bit. And these can be broken up into four phases. So first of all, artificial intelligence, the term itself, as well as the field, was coined in the mid-1950s. And interestingly, that was about the same time that Noam Chomsky published Syntactic Structures. And the impact of Chomsky, at least on North American linguistics, was to emphasize theory of language and language cognition, and with a corresponding de-emphasis on fieldwork and studying and gathering data on new languages. And this continued for the next 2 or 3 decades. And it was corresponded with a period about roughly the same time, until the late 1980s, of what's called the AI winter, when there was a lack of interest and funding in research of AI after the initial optimism in the 1950s. And things in both fields began to change in the 1950s and early 1990s. In linguistics, it's easy to point to a particular point when the change happened, and that is Michael Kraus' publication and presentation of The World's Languages in Crisis by the Linguistic Society of America in 1992, which led to the establishment of language documentation as a recognized subfield of linguistics and a general emphasis and re-emphasis and resurgence of fieldwork, the process of recording, documenting new data in new languages and analyzing and annotating that data for linguistic study. The change in AI was more gradual, but the most interesting point in this period was around 1997 with the emergence of new state-of-the-art algorithms called machine learning. And these machine learning models happen to have a very strong dependence on having lots of data. Now, the next stage, and I think kind of what starts to bring us to our kind of current phase in the relationships between these two fields, it started around 2014. It's what's sometimes called the deep learning revolution. The deep learning is a type of machine learning. But it's slightly different, and one of the significant things about it is it's dependent on having even more, lots and lots of data, and that data has to be annotated with important information. Perhaps unsurprisingly, around this time in artificial intelligence, particularly in the area of artificial intelligence that focuses on language, which is called natural language processing, or NLP, several things happened around 2014, 2015, 2016 that brought attention to a new challenge. What do we do if we're working with a language where the data is limited? Excuse me. And these things spurred a small but steadily growing interest in what are called low resource languages, languages with limited data resources for NLP technology. And I think this is best illustrated last year at the main conference of the Association for Computational Linguistics, ACL, which was in Dublin, Ireland. The theme of the main conference was low resource and minority languages. So this is a slow but steady growth that has happened in the field of artificial intelligence, and a lot of research has happened, a lot of experimentation. However, the same can't be said for linguistics. So if we take, for example, the basic linguistic steps, basic linguistic analysis that's illustrated in the production of interlinear gloss text, where we transcribe a recording of a language, we break the words into their morphemes, we gloss those morphemes, we provide free translations, and add other important linguistic annotation. We annotate each line with additional information to study that language. Then we don't see very much influence at all of the advancement of AI. And in fact, the approach by linguists to these basic tasks really hasn't changed since the late 1990s when the software tools that are popular today first came out. And this is despite the time of tremendous growth in artificial intelligence and interest in low resource languages. So this lack of change in linguistics, or this lack of interaction between AI and linguistics, has led to what some have called the greatest challenge and the greatest barrier to the advancement of linguistics, which is what is sometimes called the annotation bottleneck. It's the reality that these basic steps and these that are needed to create data that is usable for the study of new languages and the advancement of our theories, they just take a lot of time. The steps that we need to take, transcribing, interlinearizing, annotating, translating, etc., with the current methods are creating a bottleneck that is detrimental to our field. And that leads us to the current state, current situation where we are today. So what we have is linguists and community members working to document, record, and archive endangered language data, but the processing of that data for usable purposes is caught in this bottleneck. Now, community members have greater access to this data because if the language is not highly endangered, they don't need necessarily to have the translations, but without the additional linguistic annotation, even their ability to use the data for, say, the development of language learning curriculum is reduced. And in particularly, this bottleneck affects linguistics, where linguists who don't know the language, who aren't familiar with the language, are not able to use the data without this annotation. But not only that, the same sort of important annotated information that we need for linguistics is the same sort of annotated data that is needed for the advancement of natural language processing. So it's a bottleneck not just for linguistics, but also for NLP for these languages. However, this is also a point of hope, because if the data that is needed for NLP is being produced by linguists, then it stands to reason that NLP can also help us with this task. If we can take the data that we do have available and develop some NLP models, then we could potentially apply it to our challenges to assist linguists and assist the advancement of the science of linguistics, as well as community members. And that is kind of where we are today. The technology exists, but there's still a gap. And that's our current situation. But I don't want to leave you without hope. I want to give you some examples of the potential applications here. So I want to wrap up with two examples. One where you'll see that there has been some application to the field of language documentation description, and another example where it's still a potential application. So first example is the area of transcription. And this is an early step, of course, that we need, and therefore I think more work has been done to apply this to language documentation description than other technology. This is the technology is called automatic speech recognition, or ASR, which is the same technology you use when you talk to your phone to write a text instead of using your thumbs. And because it's such a needed and more or less well-developed area for language documentation and description for low resource languages, I can give the example here of one tool, a software tool that is more accessible to linguists than a lot of the other examples that I could bring. So there's a software called ELPIS that you can, if you have transcriptions and audio files of the language, if you have some rules that will account for the punctuation in the orthography, and rules that account for pronunciation or the correspondence between the orthography and the International Phonetic Alphabet, then this is a tool that's well worth downloading and playing with and seeing if you can get it to run on your data and see what kind of results it can produce and how helpful it might be in your project. The second area is in the discovery of morphological inflectional paradigms. So we can imagine a situation on the field for a linguist where they've documented some natural text, transcribe some of them, and then proceed to do a morphological analysis. And at some point after they perhaps have determined some basic morphological facts about the language, they want to go the next step and determine what are the inflectional paradigms of, say, this language's verbs. What are the various forms that can occur? Well, in natural text, you expect there to be gaps. So if you start by creating or deducing what these paradigms would be from the natural text, there's going to be gaps. So for example, you can fill in what you have, but you'll see perhaps that there is a first singular present tense form for the verb in Spanish to eat, como, but you won't see the corresponding form, first singular present, for another verb, such as the verb to love. However, you can analyze the form and come up with a hypothesis of what that missing form might be, let's say amo, which can then be taken to native speakers to test. Well, it turns out the computers are actually pretty good at this task as well. And in fact, they can fill in those gaps and with some fair degree of accuracy with as little as 1,000 random forms as examples to train on. And across a variety of languages, it can do this. Now, I haven't really seen much attempts to apply this to the practical task of documenting and describing a language into linguistic analysis, but you can imagine how it could be applied. This could be turned around then to automate or assist the linguist in glossing the rest of the transcribed text by guessing at the forms that it has not encountered yet, as well as the ones it's already seen. But I also want to bring your attention to something else here. Not only do we see in this particular area that the computer has the ability to address the bottleneck that comes from the time needed for repetitive and mechanical tasks, we also see the potential for AI to help us in more advanced tasks, because what the computer is doing here is actually building hypotheses about the language. It's building a hypothesis of what are these patterns that could then be used by the linguist to test and to build faster, more rigorous, consistent, because computers are very consistent, hypotheses, as well as building data-driven theories about language and linguistics. So I hope these examples have given you, I hope it's done two things. First of all, I hope if there's any sense of fear or intimidation that you have about technology and linguistics, I hope this talk has reduced that a little bit by putting it into context and showing you what the potentials are and what has been done. But I also hope it's given you some hope and some excitement about what still is possible and very possible. There is a gap between the fields. The potential is very great, but the practical reality is less developed. And so I hope that perhaps after these talks that will be following, you'll feel more excited, more brave to go out and attempt to be the person who throws a rope across the gap and attempts to build a bridge between the fields. It's a high risk. It may not work out well, but it's also a potential high reward that I think that all of us as linguists, also in the field of technology, and the community members themselves can benefit from. So it's well worth the effort. Thank you very much.